My name is Gavin Howard, and if you can't figure out, I'm giving a presentation. This is language design in real life. If you're not here for this presentation, then don't leave. I want you here anyway. There's very few of you, but we'll go ahead and get started real quick. About me, I'm barely 22. I started programming at 16. You'll never guess what I started programming on. Yeah. But then I got into Java and Android, and I really enjoyed it until I learned C and C++ at BYU, Idaho, and then I was like, Java sucks. And you really don't think that someone start in their language and they think it sucks. But I do. I'm a student at BYU. I was just barely accepted into the computer science animation emphasis, so woohoo. So why I'm qualified to give this talk? Yeah, I'm not. But I took over the LFyre project from the guy who started it. Name was Massimiliano Ghilardi, and yes, I have practiced saying that. It was inactive on GitHub, and I called him up, and I was like, I'd like to resurrect this. And he let me, and I feel sorry for him because I kind of changed everything. But I've been designing LFyre for over a year now. It's probably been about a year and a half. That's just design work. I've done a little bit on the compiler, and you'll see that tomorrow if you come to my talk. But I may be young, but I have quite a bit of experience. This has given me a little bit more education than I thought I would get. And quite frankly, it's more useful to me than my education at either BYU, Idaho, or BYU. No, not joking either. Really, write a compiler. Design a language, it will make you the best programmer. About LFyre, real quick, statically typed, compiled, automatic memory management. I don't quite know how I'm going to do that, but I do know it's going to be there. Pythonic syntax, and you'll see an example of that later, is completely compatible with C, and that may shock you, but it is true. And it has Lisp extensibility, which was quite a pain to put in the language, but it was well worth it. So this is the overview of the talk. I have 7 design principles, and what I'll do is I will lay out my experience with these principles and why they became, to me, as being important, how they apply to programming languages, and how to apply it generally for any design project. And I will list these from most to least important, mostly because I don't want to take the chance that you'll be asleep at the end of my talk, so I'll give you the important stuff first. Then if I have time at the end, I'll take questions. So, first principle. Choose your goals. Top goals. And prioritize them. This is very crucial. What is most important? This is crucial because when you get stuck on a decision, this is how you break the tie. What is most important? Your top goal will be the thing that breaks the tie. Like, for example, so of course you always weigh decisions against these goals, but and never forget why you ordered them that way. I forget how much I put on this slide. Never forget why you ordered them that way. For me, I won't ever forget. It was actually this time last year at this conference. There was a man who's actually part of the Openwest team named Joseph Brower. He's the guy with the video game downstairs. And he took a look at my website and he's like, Gavin, you don't have a focus. And I'm like, no, I don't. So within about 3 seconds, it dawned on me what my focus was. Error-free programming. And that became my number one priority. My second priority, powerful programming, which is why you have Lisp extensibility in there. Fun programming. Quite frankly, it sucks to program in Java. It's less sucky to program in C and C++. And then, of course, systems programming. I wanted to be able to, for some reason, I'm really hardware. In that order, okay? That is important because I've reached decisions where I'm like, okay, what in the heck do I do now? I've got I've got two conflicting things that I can decide here. So one of them, the big one, is garbage collection or automatic memory management. Like, it's a big deal. There are programmers that won't use the language unless it's got it. There are programmers that won't use the language if it does have it. So it's just like, oh, well, what do I do? My first goal, error-free programming. You cannot have error-free programming unless you have some type of automatic memory management. That's a tongue twister. So when I thought back to that, I'm like, oh, crud, I got to put it in. But then my second goal, powerful programming, I was just like, okay, how can I make powerful programming still very much a part of the language? And the answer was to give the programmer the ability to control the garbage collector or however else I do memory management. At the end of the day, everything will be automatic, everything will be safe, but if you want to release something early, it will release it, and everything's hunky-dory. You can still use LFyre for low-level system stuff, but it is error-free. That is a big example of putting your priorities first and making sure you always follow them and always remember why you put them that way. So in general, decide what is most important at the beginning of a project. This is by far your most important decision. This will affect every other decision you make. You will constantly find yourself going back, okay, how does this apply to error-free programming? How does this apply to powerful programming? You've got to make the right decision here, and quite frankly, we all know what's most important. That's why error-free programming for LFyre is most important. We just want good software. So generally your top goals should be fairly obvious, but make sure you follow them. Never, ever back down on them. Second, choose your non-goals. Okay? Non-goal, element that does not factor into a decision at all. Like, there's nothing there. Like, it doesn't even come into your brain. What this also means is you don't need to prioritize those non-goals because, well, they don't have a priority over each other. They all have a priority of 0. So don't worry about prioritizing them. LFyre's non-goals. Popularity. This was actually a crucial moment in LFyre's evolution. It was early on, and I was trying to decide syntax of all things. There's C syntax and there's Python syntax, and quite frankly, I felt that the lightweight, readable Python syntax was the right way to go. But then I read The Next Big Language by Steve Yegi. I don't know how you pronounce his name. I don't know how many of you have read his post. I have a link later on a later slide, where he talks about C or C++-like syntax is the standard. Your popularity will fall off as a direct result of how far away you deviate from it. And I thought about that a lot. Like a lot. Hours on hours. And I'm like, okay, what do I really want to do? Do I want to be popular? And I decided in the end, no, I don't. It's nice, but not important. I want to make the language right. Second of all, like Go, for those of you who attended the last presentation, I'm not in this for language design research. I'm in it to make software. Because at the end of the day, I'm a coder. People say code monkeys. Yeah, I don't care if that term is applied to me because I write code. So, in general, decide what doesn't matter at all. And don't let those things affect any decisions. All right, third, pride hurts projects. If I were prideful, I would not have taken a lot of suggestions I've received from the one man who is considered the only contributor to the project besides the founder and myself, and that is Mr. Daniel Fackrell, who has given me a lot of advice. Okay, I'm dumb. Okay, I can't have pride. So don't let your pride get in the way. A lot of people have already had great ideas. We saw last presentation Go with concurrency primitives and embedding and not using inheritance in object-oriented programming. If those people's ideas fall into your goals, which we defined as our first principle, use them. Not invented here doesn't apply. Okay, change your mind. If you need to change your mind, change your mind. Okay, we all make mistakes. We're human. If you're some kind of demigod, I don't want to talk to you because you're prideful. Because you're not. Okay, admit your mistakes. We make mistakes, especially me. Example. These are some of the links of research I did for LFyre. There's the next big language. 3 cool things about D. D was one of the other languages I focused on a lot. I spent 80% of my time reading on the internet. Okay, how can I do this better? Talking to people, coming to Openwest and presenting. You've got to do research. One example was error handling. You'll never believe where I got LFyre's error handling system. Some of you probably don't even know the book. Physically Based Rendering by Farr and Humphreys. They have a system in there where they treat errors differently based on the severity of the error. And that was kind of obvious. And it was kind of important for LFyre, considering that its most important goal was error-free programming. So, I went everywhere. I searched high and low. Even a book about graphics programming, I found what I needed. These are some decisions I changed. Templates. And you'll see that later. I changed it 5 times. 4 times. Made the decision 5 times. Maps. I originally wasn't going to put maps into the language, but they're going to be there. License. I originally started with GPL version 3. I did some research into that, and I decided that going with a more open license was more appropriate, so I relicensed everything to Apache. Macros. There's actually a very famous post on my blog, which I'll have a link to later, where I soundly reject macros. I'm like, the post is called Lisp and Academia, where I just basically wailed on people in academia. I was like, they don't know what they're talking about because they're about researching, and this is about practical things. That came from a conversation I had with people who knew Lisp here at Openwest last year. And they were saying, you got to put macros in the language. And I'm like, I looked them up, didn't understand them, rejected them. They're now in the language because I understand them better. I don't understand them completely, by the way, but I understand them better. In fact, I managed to get macros with infix syntax, which was quite an achievement, I think. And there were a lot more decisions that I can't remember. This is more true to life. The Go programming language, okay? We had Ken Thompson. Sorry, I'm not a teenager anymore. We had Ken Thompson, who helped write Unix. Rob Pike, who invented Unicode, or helped to invent Unicode. And Robert Grissomer, who wrote V8 and the Java hotspot virtual machine as well. Okay, Rob had worked with Ken at Bell Labs. They were basically peers, but Robert wasn't even in their league. But they trusted him. There was not a single thing that they put in that language that wasn't unanimous. The reason was because Robert was a Windows and Java guy. The other two were C and Unix guys. Two completely different worlds, and mixing those ended up producing a very good language. Go is very good. So, in general, research. Okay? Ask for opinions. A lot. Even if you're an expert. Okay? I'm an expert in LFyre. Doesn't mean I know how to do it best. Right now at BYU, because I'm on the animation emphasis, I'm taking this class called The History of Creativity. You wouldn't think it's a fascinating class, but it's probably one of my most fascinating classes ever. We talk about basically from the start of civilization, how creativity shaped civilization. And in every case, when some invader come in and wipe everything out and mix two peoples, whatever, when the tribe of Judah was conquered, or when the Sumerians were conquered, or anything, that mixing ended up producing tons of creativity over the next few years, and it might peter off like it did in Egypt, but that mixing was crucial, absolutely crucial. Perspective, it's all about perspective. There's this diagram on the internet, I don't know if you've seen it, where there's a big circle, and then inside the circle is a little tiny bit. That's what you learn in elementary school. Then in high school you learn a little bit more. And then you get a bachelor's degree and you learn a little spike. Then you get a master's and you stretch out to the very limit of the circle. And then you push the boundary of the circle, and that's your PhD. And suddenly the world looks like that tiny little spot you've got. It is now huge to you. Well, guess what? There's a whole nother circle you don't see. You've got to remember that you don't see everything, and change your mind. Really, change your mind. Don't be afraid to change everything, especially before you set things in stone. Fourth principle, trust your instinct. I know that's really cliche, but I want to tell you how to do that. I just remembered. I didn't say anything about questions. Yeah, we'll take questions at the end, but if you can remember the slide number as well so I can get back there quick. Anyway, trust your instinct. Cliche, but true. So how do we do it? Don't like a decision? Your gut's telling you to change it. Now, in some cases, there may not be another decision. So you make the decision, but you keep looking. You have to keep looking. This was the most important thing, one of the most important things in LFyre. LFyre has generics. It was difficult. They had to be type safe, absolutely type safe, because LFyre is statically typed and strongly typed. But I didn't want templates. They were obvious, but I didn't want them because they suck and they generate a lot of code, and it makes the compiler very complex. The result is LFyre has generics, type-safe generics, but no templates. Curious? You'll never believe what I did. This is LFyre code, and
I can't believe it.
thank you for that. Thank you for that. Okay, this is going to require me to explain a few things. All right, this types are first-class types. Reflection is very strong in LFyre. A decision that was kind of built in the language for me. LFyre is an acronym that stands for language, for flexibility, reflection, and extensibility. So reflection was going to be in there from day one. I'm glad it is. That type means, okay, that variable is a type. So basically, you pass in two types to the constructor. This is the constructor. And you set those types. And then you make arrays of those types right here. And you base that is how you set it. Now, you can see here in this add, this any interface, because it's in an interface, just like Go, accepts anything. But you can check the type here just like you would anything else, just like you would any other normal type. And you call the constructor like this, map m, and now you've got a map that maps integers to strings. Completely generic, completely type safe, no templates. Thank you very much. Process. I wrote about templates 5 times on my blogs. 4 of those times was exclusively. First, I added them and changed the syntax, then removed them, then added them again. And finally, I figured out how to do it. It took adding other things in the language to finally realize, hey, I can do this another way. And that will actually come later. So in general, when you make a decision you don't like, accept it for now, but keep looking. There is a better idea somewhere else. Trust me. In the end, when you're coming to the end, do not accept mediocrity. This is a design. You can't be mediocre in the design. Maybe you've got some bad coders somewhere, and they'll be mediocre in the implementation, but it will definitely be mediocre if the design sucks. So do not accept mediocrity. Fifth, use what you have. This goes back to what I just did. LFyre got generics through reflection, which seems totally random, at least to me. What I did is I was like, I need a new feature. And I was thinking about it, and suddenly it dawned on me that I already had what I needed. Look for that. If you need a new feature, can you get it with what you already have? So in this case, generics, I extended reflection and promoted types to actually be first-class types, which I've heard ML does, but I'm not sure. Error handling. I had to extend enums. I've only seen that and never heard it pronounced. Macros. I extended properties. Now properties, I originally put them in for efficiency only. They were supposed to be the getters and setters because I hated the Java get whatever, set whatever. I hated them. So I'm like, okay, what I'm going to do is I'm going to create a system where you can access something like a field, but if it's on the right side of an assignment operator, it's a getter. If it's on the left side, it's a setter. So that way you have the uniform design principle, uniform access principle, I should say, and everything's great. You don't know if it's being calculated or if it's just data. Plus, add interfaces into that, and you can require certain structs, objects to have certain pieces of data. So I originally added them for efficiency. In the end, I figured out, well, I can't do the same source transformations that Lisp can unless I can modify the precedence and associativity of operators on the fly. So precedence and associativity became properties, constant properties, and suddenly macros became very possible. So in general, when you add a new feature, first of all, make sure it stands alone. Like it's completely orthogonal to everything else. To do that, look among your existing features and if possible, extend them to add the new feature. If not, it stands alone and can be safely added. Sixth, I've only got 7 and it's 25 after. Okay. Clean Cruft often. This kind of goes back to the last one too. Sometimes you'll add a new feature and you realize it's more orthogonal than one you previously added and they overlap. So Cruft is features that you can implement using what you already have. The last one was about making sure you didn't add Cruft. This one is about taking it out once you get it. They're both important because you will get Cruft because you make mistakes. So you get rid of it, especially before you set it in stone. There's a quote on the Golang mailing list where once the poster said, I think it was Robert Grissomer, said, once you add a feature to the language, you cannot take it back. And the reason is because of backward compatibility and all of that thing. So get rid of them as soon as possible. Example, design by contract was originally in LFyre. Of course, LFyre's one main focus is error-free programming, so design by contracts seem to be a perfect thing to add. Well, I can simply use assert. That is why assert's in the language, is because it helps with error-free programming. That is another example of using your priorities. Okay, assert, you can write it as a macro. Yeah, but really error-free programming came before powerful programming. So assert is built into the language. Inline assembly. This was actually one of the features I was most excited about for some reason. I thought, you can have inline assembly, and instead of defining registers, you define variable names, and it's all great. Well, you can declare external functions, which are written in assembly. Plus, you can add them with macros. And there are more. There are a lot more. I just couldn't think of them at 3 in the morning when I was doing this. So, in general, any design project, find features that don't stand alone and remove them before they become trouble. All right, 7th principle, last principle. I'm going to get you guys out of here earlier. I'm going to have a lot of questions. No special cases. What this means is there should never be a special case. And how you find them is quite simple. Oh, yeah, there are also design flaws. By definition. I was very, very careful about special cases. I learned my lesson from Java and C and C++ that special cases just don't work. So I'm going to talk about another language, Go. Now, Go is a wonderful language. To be honest, about probably 50 to 70% of LFyre is pure Go. It's not perfect, though. That's why I'm writing LFyre. Go has no generics, except for built-in maps. Everything is passed by value, except for map slices and arrays, which are passed by reference. There should be no special cases. Never say except for. Except is a word that means special case. Okay? If you have to say except, change it. You never want an except in your language, unless it's exceptions, which I don't know about that. LFyre does have exceptions, but they're different. Keep looking for a better solution, something that covers everything. This goes back to having things that are completely orthogonal. If it's completely orthogonal, it doesn't run into other features, and it will cover an entire dimension of what you are trying to design for. If you've got a special case, that means it didn't quite cover all of the dimension you're trying to cover. So it needs to be changed. And again, research, ask opinions, mix ideas. So, in review, 7 principles. First of all, choose your goals from the outset. Prioritize them. Make them important. Make sure you make decisions based on them every time. Every time. That was the single best thing that happened to me during LFyre's evolution, was coming to this conference and being told, Gavin, you don't have a focus. Choose your non-goals and don't let them affect anything you do. Now, these non-goals may happen. Like, for example, in the very quite unlikely chance that LFyre does become popular, one of its non-goals did happen. But it wasn't a goal. It was a non-goal. It wasn't important to me. 3, pride hurts projects. You're not all-knowing, even if you have a PhD, because your view of the world is very small. Very, very small. If you don't have a PhD, your worldview is not very specialized. So ask opinions, research, change your mind, do whatever you have to get rid of your pride. It's a very Mormon thing to say, and it's a good thing we're in Utah. Trust your instinct. Might also be very Mormon. Some might call it the spirit, and I actually think that there was a lot of inspiration in creating LFyre, but maybe I'm just biased. But trust your instinct. If you do not like a decision you had to make, keep looking. I kept looking, and I think that LFyre probably has the best generic system of any language in the world. But again, I may be biased. Use what you already have. Add things carefully. Make sure that when you add something, it is completely separate from everything else and helps to cover one more dimension, one more full dimension with those other features. Along with that, clean out the cruft. That will inevitably happen. You will make decisions that make things overlap just slightly, maybe just slightly. Maybe you need to tweak it just a little bit. But clean out that cruft. It is worth it by far. And no special cases. Don't put in special cases for anything. If you're going to make everything pass by value, you make everything pass by value. If you're going to make everything pass by reference, you make everything pass by reference. If you're going to have a way to initialize certain objects, you better make that available to every object. Okay? No special cases whatsoever. That is the end of the presentation. Thank you for listening to me, and I guess I'll take questions now. Yes?
So, what are the guiding principles then specifically for error-free programming? How do you prevent errors that you don't even know a programmer would write?
Well, I think the best way I explain that is go back to the Zen of Python, where it says errors should never pass silently unless explicitly silenced. Errors will inevitably happen, and LFyre tends to be the language that will fail spectacularly, but at compile time, as much as possible. And I actually think that's the right way to go. I mean, you will have programs crash, so I won't eliminate crashing like I wanted to. That was initially my view of error-free programming. But in reality, error-free programming is about finding the errors quickly in development before they get released to the wild and eliminating them. Okay? So I saw one example where a guy actually ran Hello World with a read-only standard out, which doesn't make sense. But you have all sorts of random things happen. And he rated the languages that didn't do anything or had a runtime error, or well, basically didn't do anything, didn't tell him that there was an error. He's like, these suck. But there were a couple languages that are like, I don't know what to do with this, and they failed. Same thing with LFyre. If you gave it a read-only standard out on Hello World, it would fail on Hello World, and it would tell you. So you could fix the problem. So, for example, if you did have an exception passed from your printf function or whatever, you could handle it and then be like, well, I can't really run the program, return a non-zero exit status so the operating system knows that something went wrong. It's really all you can do at Hello World, but that's basically my philosophy, yes?
It seems like the way you were doing typing, it's all going to have to be done at runtime, the checking?
Mm-hmm. Except no. Things are statically things are statically typed, so if I
expression with the if
21.
Yeah, sorry.
Whoops.
Wait, that one's empty.
That one's empty because I was going back. Slide 21. Yeah, slide 16, 21. All right. Okay.
Didn't expect you to actually
There we go.
remember that, did you?
23. All right. Okay. It looks like it's checked at runtime, but in reality, this line is the key to making sure it's actually going to work. The programmer had to put this in. He actually had to check the types. But if you look at this type, it's a type. It's like int. That key type is always going to be a type. So underneath the hood, it's going to be like an enum that becomes like one for int, one for unsigned int, all of that stuff. So it is still statically typed, but like Go, it has the feel of a dynamic language.
It seems like your generics are just like anything goes compile time.
Yeah.
So what happens if you remove
if you remove that if statement, then you could have an exception that says this is the wrong type. But that is one of those things that, I still haven't perfected the language yet. But yeah. So yeah, it's not perfect. If you have suggestions, come up to me afterward and chew me out. I seriously, I need help. I'm only very young. What?
Would that crash the program?
It might if you don't check for it. But one thing the compiler will do is it will issue a warning for unchecked exceptions. It will know when a function throws an error, and it will issue a warning when you're not dealing with it. Any other questions? Yes?
How far along are you?
Well, tomorrow the hope is that during my presentation, the very first LFyre program will run. It will be Hello World, and I will do it live in front of an audience, and I'm hoping it will work. But right now I'm bootstrapping the parser, the Lexer and the parser, and eventually the full compiler and the runtime. So still working on that, but I'm going to school. Looking for sponsors, by the way, so I don't have to work. I could work on LFyre. Yes?
So is this just kind of a general purpose language, or does it have any particular domain that it...
It doesn't have any particular domain. Because it's C binary compatible, you can talk directly to the operating system, so if you need to, you can. But like Go, it feels very lightweight. I mean, I've written very little LFyre code because there's no compiler yet. But the stuff I've written was enjoyable to write. Whereas my Lexer, when I had to write my Lexer over 3 days, preparing for last Openwest conference, it was very difficult. I didn't enjoy it. So eventually, LFyre will end up with a compiler and interpreter where you could put hash bang and just execute. I intend it to go across the entire spectrum of languages and do it well. But we'll see if I actually do that. Yes?
So what things do you do to make sure that LFyre is broad enough to handle all the programming you want it to handle?
Well, the key to that, I believe, is the macros and the extensibility, as well as the interface system that I borrowed shamelessly from Go. Like, for example, you've got this right here is an interface called Any. That is actually generated by the compiler. All the stuff that you need there is like size of, type. Like you can actually, like this is a property on the Any interface. That's kind of the key. One thing that they talked about with Go is they can combine interfaces and kind of like Unix pipes and keep things going. If you read up on Plan 9 and its implementation, it had a file system API of 14 functions, and anything that implemented those 14 functions could talk to each other. So they give an example, like for example, there was they would import a proc tree from a computer that didn't have a network connection, but they'd import it over the network from another computer, and then they'd run a remote debugger on the process, and they did it every day. That just worked. All the design stuff for that comes out of Go. The same guys that worked on Plan 9 worked on Go. It seemed to me like the right thing to do, and the more I look at it, the more it seems like the right thing to do. So that's how I intend to do that. I don't know, for what it's worth. To be decided, to be seen, we'll see. Yes?
How is scope handled?
Exactly like Go. You have packages, so
No Go.
So I'll explain it real quick. You have packages, and everything within a package is visible to everything else in the package. So you might have private members of a struct in a package. Well, an outside struct in that same package can still see those private, very private members. If you want to restrict the access, you just make sure that you define your package very small, and packages are meant to be small. Scope, you have your if, your else, your loop, scope the same. There is one extra scope, and that's file scope. When you do an import statement, you can rename the package that you imported in that file in case you have a name collision. And that's basically all the scope. Did that answer your question? Okay. Yes?
Why did you decide to design a new language?
Okay. Well, this is kind of a little longer story. Do you mind? I was at BYU, Idaho, and I'd written Java, never had to deal with memory or anything. I was writing C++ for the first time in an object-oriented class. And first project, I got a seg fault. What the heck is a seg fault? And I was just like, whoa, how do I debug this? I looked it up, found out what it was, didn't quite understand it, tried to debug it, couldn't. I almost had to turn that project in late. And I was just like, okay, I love C and C++. In the short time that I'd worked with them, I loved them. They were powerful, they were great. C is still the king of all languages. If you want to talk to hardware, you have to talk to C, which is one reason why LFyre is completely compatible with C. But I was just like, we can't deal with seg faults for forever. That's just, security errors, crashing, all those sorts of things that go with that. We just can't deal with manual memory management. But it is so nice in some cases. So I was like, okay, I started formulating in my head something that is actually, I didn't know it at the time, but was quite close to automatic reference counting that is done by Objective-C. Look it up if you need to. That's one of the things I researched as well. I researched a lot of it. Clang implements it. So I started formulating that. I'm like, a compiler could probably check. I didn't quite understand alias analysis and all that. So I know better now, but I had this idea of I want a language that is powerful but completely safe. And then one day in December 2012, I was almost the end of the semester at BYU Idaho, and I was like, something that's going to set me apart on my resume is actually leading a project, especially if it's an open source project. So I was like, I'll go onto SourceForge and look at the inactive projects and see if I can resurrect one. And LFyre came up, and I just kept going back to it again and again. I liked the ideas, adding keywords, which turned into macros, and operators, and being able to completely redefine the language if you wanted. And I was like, okay, this is the project I'm going to do. Plus, I can try my memory management ideas. And so I called up the creator, and he gave me permission, and the rest is history. Any other questions? Yes?
So in special cases, technically everything is a special case, but you want to avoid all special cases, so you create a generalized process.
Mm-hmm.
But why isn't things like if or loops or the basic commands that you expect to get in a language, why aren't those considered special cases? Can you recreate if? Can you recreate loops?
Well, Lisp did.
Okay.
Lisp originally didn't have any conditional processing or loops. They added them with macros. So you can.
Okay.
It had one conditional.
What had one conditional?
And you can build all the other conditionals off.
You are the guy.
I'm the Lisp guy.
Yes, you are. Okay. Ladies and gentlemen, this is the guy that told me I was wrong and was absolutely right. I repent of my stupidity now. Yes. Okay. So add one conditional, but it didn't have loops.
So the one thing is an if condition, and through that you get basically Turing completeness.
Yeah. Basically, it's can I make a decision based on what I do, and yeah, loops are a special case of ifs. But they're also really compact and nice to have. So yeah, everything's a special case of everything, but I'm speaking more of the things that are really obviously special cases. Like, for example, design by contract. I originally had no assert in the language, but I had design by contract. And it took a lot of thinking for me to realize that underneath the hood, design by contract is just doing a bunch of asserts in the right order at the right times. So just assert. Okay, a design by contract is basically, okay, you have a function and its parameters. When you enter the function, the parameters have to satisfy certain conditions, and when you leave the function, the return values have to satisfy certain conditions. So basically, those turn into asserts. They're all Boolean expressions. You can use assert.
Like interfaces, that kind of idea?
It's basically saying, I have a contract I need to fulfill, and I can't fulfill unless you do your job right. Like, for example, say you've got a date string to Unix long function. The contract for entering that function is you have a valid date string. If you don't, I'm going to throw up on you.
It has to match the right signature.
Exactly. And when you exit the function, the Unix long has to be correct. So that sort of thing. It's basically you do everything right, I'll do everything right, and what comes out is non-buggy.
Which provides the modularity, so everybody can just they can all trust each other to
Exactly. The biggest language that does this is EIFL. I originally found it in the Cobra programming language, and then found out it came from EIFL. So if you want to research design by contract a little bit more, go to EIFL. But basically, underneath the hood, they're just doing a bunch of asserts in the right order at the right times, and so I was just like, well, I can cover more area if I just simply use assert.
If those asserts don't fulfill, does the program crash, or?
If the asserts don't fulfill, that's actually what happens. That is one reason why I made unchecked exceptions warnings in the compiler. Is one thing you need to guarantee when you come out of a constructor is that everything's initialized. And so there will be implicit asserts at the end of a constructor, which basically an assert will throw an error. And
will that error crash your program?
it will if you don't cache it. Because if you come, one thing that is required for LFyre has non-nillable types, which you've got to make sure that it's not nil. And that includes pointers, which is a nice guarantee, but you've got to guarantee it. So if you don't have that guarantee, you've got to bring the program down. But the point is to do that as fast as possible during development so that the developers catch it, eliminate it, and get it out of the way. Does that make sense? Now, the design isn't perfect or even close. I still have things to work through, and I still need ideas from people, which is why I'm glad more people came to this presentation than my presentation last year. But yeah, help me work with this. You know, it's an open source project. It's on GitHub. I probably should have put the link, but you can see the link on my website.
So in the case of the any type, the only reason why we're having to do type check there is because you're using a type any.
Yeah.
Okay.
Yeah. You do have certain guarantees with the any type. Like, for example, you have the size of, and you have the size of. You can look at its type, like reflection requires. But other than that, you don't have any guarantees. You can do a typecast, but that will throw an error if it doesn't work.
What's your take on functional versus procedural?
I'm generally procedural, but LFyre does have lambdas, and you can call them right there. So just I understand that there's certain things that are easier with functional than procedural, and I know they're both the same thing, but quite frankly, one's more powerful than the other in certain cases. So, well, ladies and gentlemen, that is over time. I'm sorry. I answered a lot of questions. I hope you come back and talk to me. I'm not exactly I don't bite, but thank you for listening to me, and have a great day.